All right, today let's learn about integration factors. It is a method to make differential equations exact. We will solve the question dy over dt plus 4y equals 8 using 3 different methods. We need to begin by identifying the integration factor. In the first video in this series, we talked about the general equation given as dy over dx plus p of x times y equals q of x. Since our variable is t, let's just change it to that in order to avoid confusion. We derived the method on how to find the integration factor, mu, and that came out to be equal to e power, the integral of p of t dt. We can identify the function p as 4 in this example, and integrating 4 gives 4t, so the integration factor is e power 4t. Next step is to multiply this on both sides of the equation. Then to solve it, we have 3 methods. First, let's do it using the exact equations method, or the one we used last video. So we need to get it in the proper form, which requires us to take the 4y e power 4t term to the right side, and then multiply dt on both sides. Then we can take this term back to the left side, and we can see that it is in the perfect form. We identify the term m as 4 e power 4t times y minus 8 e power 4t, and the term n as e power 4t. If you want to confirm if it is an exact equation or not, you have to take the partial derivative of m with respect to y, and the partial derivative of n with respect to t. These both come out to be 4 e power 4t, which confirms that the equation is now exact. Now, to find the solution function, we integrate either m with respect to t or n with respect to y. For the sake of simplicity, let's integrate the n term. That gives e power 4t times y plus c of t, and the function f is a constant too, which we can call c. The two constants can be combined to give a new constant which we call b. Therefore, b equals e power 4t times y. The e power 4t can be divided on both sides to get the solution y equals b times e power negative 4t. Next, we can do it using the integration factor method. Personally, I prefer using this method or the third one, which we will talk about later in the video, as they are much simpler. Back to the question, we identified the integration factor and reached this equation previously in this video. Now, how we solve this is by setting up the left side as a term being differentiated. This will always be the derivative of y times the integration factor. You can also check this if you want, using product rule. It will come out to be the same thing. Now that we have it written as this, we can integrate. However, first multiply dt on both sides.
Wait, why is it just d on the left side?
Well, you have the y here, which multiplies with it, and essentially you can write this as e power 4t times dy. The right side is 8 e power 4t times dt. We integrate both sides to get y times e power 4t equals 8 e power 4t over 4, which is just 2 e power 4t plus c. Divide e power 4t on both sides to get the final answer. Y equals 2 plus c times e power negative 4t.
Why is there a 2 in this answer and not in the previous one?
The answer is simple. 2 is just a constant, so basically our constant c in this case, and constant b in the last answer will differ slightly. The last method we will cover is the splitting method we used in a previous video. In fact, in that video, we did the exact same example, so make sure to check it out. Thank you, and stay tuned for the next video, where we will practice further examples using integration factors.